have no gated clocks. Now, if a customer insists on having an asynchronous reset, I usually tell them that their circuit should behave okay as long as the reset is global. But I never allow a local asynchronous reset in the design. For more information on synchronous design practices, check out the synchronous design modules I mentioned in the Essentials of FPGA Design course. As I mentioned a moment ago, using synchronous sets and resets,
okay, this we've seen before. This is how you do an asynchronous preset or a synchronous reset. If you have the preset in the event list, it's asynchronous. If you have to get by a clock to get into the always block, it's synchronous.
Is there any reason why that you know of? Why it's, because he said he only wants them to be global. Why would it be such a bad
I'm going to
thing?
defer that until we get to the Vertex 5
Okay.
coding. He talks about resets in more detail there.
with an asynchronous reset for the same reason, by not including the reset signal in the sense the flip-flop can glitch in any FPGA, usually right after the clock signal. For clarification visualization, and what we're talking about here is try to target as much of the dedicated hardware so it will save you using lookup tables and registers in your standard array logic. Plan on instantiating clocking and memory resources. As we mentioned, these are very commonly instantiated by most customers. It is possible to infer the primary functionality for the rote, simple implementations of the clocking and the memory resources. But again, the architecture wizard and core generator are there for that purpose, to allow you to instantiate those components easily. Try to use the core generator not only for the clocking and the memory resources, but also other dedicated FPGA features like the DSP slice and the FIFO logic resources. Also, maintain your design hierarchy.
Incidentally, BRAM is block RAM.
To make debugging, simulation, and report generation easier. Continuing on with the summary, case and if-then statements produce different types of muxes. As we described, case statements tend to build logic in parallel, while if-then statements tend to build priority encoders. The priority encoders tend to often make timing critical paths later on in the design. So in general, build with a case statement if you can. Avoid nested case and nested if-then statements. Again, for the same reason, it tends to build logic in series rather than in parallel, and it tends to slow the performance down. You should always build a synchronous design for your FPGA, not just for speed, but the key thing here is to save you time and make your design more productive. And we mentioned a couple key tips about following good synchronous design practices. Build with your clock enabled and use synchronous sets and resets whenever possible. Never build asynchronous sets or resets. Lastly, inferring many types of flip-flops from your HDL code is possible. And as we mentioned, those synchronous sets and resets are preferred. The first recommendation is to all...
Okay. That's the main thing out of this particular module. Now, next time we meet, what I'm going to do is give you an overview of the Vertex 5 family of FPGAs that Xilinx makes. Because that's going to serve as a basis for at least one more video, which specifically talks about the Vertex 5 and HDL coding guidelines for that particular FPGA. So we'll do that next time.